Reporting live from Iceland, we have here Dani, Kerry, Courtney, and I'm Sofie.
We will show you how to find energy, waves, and forces.
Let's start by exploring what energy is.
Energy is the ability to change the state of motion. Types of energy include kinetic, potential, and thermal.
We are stowed in the basement of the lodge because Iceland's average temperature is 28 degrees in December.
So we will demonstrate how as plates move apart, eruptions of lava occur because of the empty space of the diverging plates.
Iceland is located on the North American and Eurasian plate. Both plates are diverging or moving apart from each other, causing eruptions.
This demonstration has energy and then relocated after the eruption because it can never be destroyed.
There's usually about 20 to 800% of molten layer above the hot spots in Iceland. That supplies material for eruptions.
This relates to physics because within the magma, potential energy exists because it is stored below the surface and has not erupted yet.
We have looked back into the history of Iceland's volcanoes, and one of the largest volcanoes erupted in 1961 is called Isiska. It erupted with a plume reaching 500 meters.
If we could have found the mass of all the lava and the viscosity in which it traveled, we could find the lava's kinetic energy.
To find kinetic energy, we must follow the formula 1/2 mass times velocity squared. This is measured in joules.
Since we know that Iceland climate is very cold, physical weathering occurs the most.
The rate of the weathering in Iceland is influenced by the climate because there is a lot of freezing and thawing throughout the year. Therefore, the energy is transformed many times.
Outside the volcano, the viscosity, or resistance to flow, affects the temperature of the lava.
High viscosity.
Low viscosity.
This is because the stronger the viscosity, the more energy is required to heat the magma.
Iceland has many volcanoes. Most are shield volcanoes. These are built with many layers of runny lava.
Shield volcanoes don't have as much kinetic energy while exploding compared to composite volcanoes because their resistance to flow is low due to their running lava.
Now we will take a look at what causes many of these eruptions, plate tectonics.
As you know, Iceland is splitting along the Mid-Atlantic Ridge, a divergent boundary along the North American and Eurasian plates.
Because of this, Iceland is a hotspot. These high temperatures have a lot of thermal energy.
The North American plate has a lot of kinetic energy.
This is due to the fact that the plate has an enormous mass. Therefore, when placed into the formula, Ke equals 1/2 times mass times velocity squared. The kinetic energy is high.
Now we can look at another section of the geology in Iceland, rivers and waterfalls.
Dettifoss is one of Iceland's most popular waterfalls because of its great size.
Since the waterfall starts at a height of 44 meters, it has a lot of potential energy. Because the higher the object is, the greater the potential energy.
In the river of Thjórsa, there are many cut banks. A cut bank is the outside of a bend in the river.
The water is fastest on the outside of the river or cut bank, therefore the kinetic energy is the highest.
In the Thjórsa River, it can carry many things like pebbles, sand, and even small boulders.
This is because of the kinetic energy. The kinetic energy from the water is transferred to the rocks. The faster the water, the larger the rock it can transport.
For example, the North American plate and the Eurasian plate are diverging because of convection currents.
A force is acting upon the plates because they are changing motion.
We can now show you how forces are applied in today's geology.
But first, let's explain that a force is really a simple push or pull!
For example, the North American and the Eurasian plate are diverging because of convection currents.
A force is acting upon the plates because they are changing motion.
Since these plates are diverging, the resistance is great because they are moving apart from one another. This is caused due to resistance.
The force of the convection currents is being placed upon the plates, and they will continue to drift apart until they are acted upon by an outside force.
The North American and the Eurasian plates stayed at rest until they were acted upon by the convection currents.
This is explained by Newton's first law. It states that an object at rest will stay at rest unless acted upon by an outside force.
Scientists have noted that the North American and Eurasian plates have been moving apart at 2 centimeters per year.
A force of convection currents is placed upon these plates and will continue to drift apart unless acted upon by another outside force. We know this because of Newton's first law.
Because we know the two plates are diverging at 2 centimeters per year, the acceleration would be very low.
Because acceleration equals distance divided by time, and the distance and time are low, the acceleration would have to be low.
The North American and Eurasian plates accelerate by diverging from one another.
Because of Newton's second law, we know that if you place an unbalanced force on an object, it will accelerate in the same direction as the force.
We can also demonstrate forces in weathering and erosion. Exfoliation occurs on many outer pieces of rock in Iceland.
This can be explained by physics because when mass is lifted from another force, the outer pieces fall off. Therefore, a force is acted upon the rock to have it cracked.
Abrasion also occurs in Iceland when the rocks collide from a force by means of friction wearing down and scraping of the rock occur.
Water is fastest on the outside of the meander. This causes erosion of the cut bank.
The force is greater in this situation because the mass and the acceleration of the water is so high. Therefore, the force is
On the
greater.
other hand, water is slower on the inside of the bend, as it deposits a point bar made of gravel and sand.
This gravel and sand is let go because the force is so low it can't hold the sediment. The formula F equals m times a, Newton's second law, explains that if the acceleration of the water is slow, so is the force.
Lastly, we can look at River Thjórsa again. It's in Iceland, and because the water has a great mass, its inertia is very great.
The water is moving and wants to stay in motion, like in Newton's first law.
Let out a bit, and we now get to experience Iceland.
We're going to show you how Iceland experiences earthquakes because they happen every day here.
Lastly, we will show you how waves are connected to the geology of Iceland.
On June 17, 2000, a huge earthquake hit Iceland.
The first P wave hit at 1540-41. This is because P stands for primary.
Also on this day, the earthquake was measured with the 6.5 magnitude.
Using other information like the arrival times of P and S waves, we could calculate that the distance to the epicenter was 2,200 kilometers.
When this earthquake hit, several houses were so badly damaged they had to be abandoned.
The surface waves caused most of the destruction in the earthquake because of their high amplitude.
On April 14, 2010, the volcano Iceland erupted and caused a disturbance, like this.
This disturbance in the earth caused waves to be recorded at a seismograph station.
The seismograph station recorded the earthquake
Whoa!
to have the frequency of 1/3 hertz in 30 seconds.
So we could calculate the wavelength by using the formula. Speed equals frequency times wavelength.
Iceland volcano erupted in April.
It measured 3.7 on the Richter scale, which was developed by Charles Richter in 1935.
Like in the rest of the world, estimates can travel through Legos. So when an earthquake hits, seismologists can determine what the earth is made of.
So we know that the outer core must be liquid, based on the disappearance
An
of
earthquake
acid.
hit Iceland on September 12, 1998, with the P wave coming in at 236.15 and an S wave came in at 239.45.
We can then find out the distance to the epicenter by subtracting the arrival times.
So by using a time travel curve, we find out the distance to the
Now,
epicenter.
if an earthquake occurs in Iceland, most people use the moment magnitude scale.
This is used more to accurately measure the amount of energy released by the large waves from the earthquake.
An earthquake starts below the earth at the focus point. This is where the earth fractures. In Iceland, we can see many fractures on the earth's crust, and geologists can locate them under the surface.
Focus is the location within the earth where underground rock moves and sends out earthquakes. Seismic waves are sent out in all directions.
As you can see on this seismogram, in July 2008, an earthquake hit Iceland.
From reading the graph, we can see that the waves, amplitude, wavelength, and frequency.
We set up 5 seismic stations to report seismic wave activity.
A surface wave travels along the Earth's surface, and at least 3 seismic stations are needed to find the epicenter.